Today we'll be covering some basic curve and plane concepts in order to develop an efficient Rhino modeling workflow. So let's start off with the basics. Curves and planes. What does it mean for a curve to be planar? So the technical definition of a planar curve is that all of the points in the curve are coplanar. And if you were to draw a plane through any of the 3 points on the curve, the rest of the points would also all be in the same plane. Think of it as a curve being flat on the ground where you drew it. Oftentimes when we draw curves, this is what we want, and it can be useful for a number of things. So let's take a rectangle, for example. Right? A rectangle drawn like this is by definition planar. And if we use the PlanarSrf command in Rhino on the rectangle, we can see that it generates a nice plane. Now, this isn't anything we can't do with the plane command. So why use planar surface in the first place? Well, think about it this way. What if we wanted a surface with a hole in it? What if we wanted a surface whose profile wasn't a regular polygon? Well, planar surface can definitely do that. So let's try it out. Let's first make an irregular shape. All right. And let's put some holes in it. Anyone want to take a guess what will happen when you run planar surface on this? Yep, Rhino finds the region defined in the interior by all of the planar curves selected when running planar surface. This allows us to get surfaces that are irregular and generate planar surfaces, which are useful and necessary for a lot of modeling commands in Rhino. For example, we can extrude this. So let's try some other examples. Sometimes we might be drawing lines, and we're in a viewport where everything looks nice and flat and planar, and we can't see too much of a difference between the two lines. So we have a shape we want to draw. We draw it out just how we like, and everything seems just fine until, oh no, the line is actually not going in between the two curves we wanted it to and is curving all over the place. This is an example of a curve that isn't planar. Now, why is this happening? Well, at the end of the object, the control points are being created, snapping to each of these lines, which are at different heights. Now, in the middle of the object, if we turn the points on, we will see that they're actually being constructed on the ground plane. Well, what if we wanted this object to all be in a straight line? Now, Rhino has a built-in function called SetPt, and what that does is it allows us to select points and set their coordinates equidistant to others. So in this example, we'll want to set the y-coordinate to be equal to the other 2 points. Say OK, and we select the y-coordinate that we would like all our points to be at. They're all in line, and this curve is now planar. Now, what if we wanted all of these curves to actually be flat, the same way we see them from the top viewport, as one straight line? Well, it's quite simple, actually. So Rhino provides a function known as project. And with project, actually project has an option known as project to CPlane, which essentially projects all your geometry down into the grid that you currently see here. If we run project to CPlane on this example, it'll give us the option to delete the current curves, which we would like, and now everything is flat, just like we had imagined it. One thing to note about project to CPlane, however, the direction in which it pulls depends on the viewport in which you are currently in. If we were to undo this, move to the right viewport, for example, and say project to CPlane, it'll project to this grid as visible in the right viewport. If we go back to perspective, we can see that all of the curves here were projected onto the CPlane if they were able to. Rhino, seeing these curves only as a point, was unable to fully project them. Alright, so we've been talking a lot about planes and planarity, and the strange CPlane thing has been mentioned. But what actually is a CPlane? CPlane stands for construction plane, and it's essentially the plane that Rhino thinks about all your geometry in reference to. When you draw a curve, it's drawn on the current CPlane. Each of the top, right, and front viewports has its own CPlane. The grid, when shown, is actually a representation of the CPlane. However, the CPlane is still active even when the grid isn't shown. So this top, right, front orientations are called the world orientations of the CPlane. However, we can actually set the CPlane to any plane with any origin. Most of the time what we want is orientation, and there's a couple of quick ways to set that. Firstly, using the CPlane command, we can set the elevation of the CPlane, in this case in the perspective viewport, to a different height. It'll keep the origin the same, but the elevation of the CPlane has now changed to the top of this box. Alternatively, we can rotate it around any axis by using the rotate. Select this axis to begin, and it now gives us a rotation option. As you can see, our CPlane is now rotated. If we already have a surface that we know we want to snap the CPlane to, we can do that too. And the CPlane will orient to the surface, just so. Additionally, we can create a CPlane through any 3 points, just as we might define any other plane in Rhino. For example, there you are. Now, you have to be a little bit careful, right? The CPlane can't be undone by Control-Z. If we Control-Z, it merely undoes the previous actual geometric command that we ran. To get to previous CPlanes, we can use the previous CPlane button, which essentially runs through the CPlane command and selects the previous option. If we want to go back to the CPlane we just had, we can use the next button. However, what if we want to set the CPlane back to what it was originally? Well, that's what the world orientations are for. So if we select CPlane, so world, and top, we're back to our default viewport for the perspective view. Now, CPlane is highly useful for reorienting geometry quickly. If we were to, say, set the CPlane to one of these funky surfaces on the pyramid, we would easily be able to then rearrange shapes onto that surface using the RemapCPlane command. For example, it takes the CPlane from one of the viewports and changes the referencing of the object to the CPlane from one of the other viewports, like so. As we can see now in the perspective viewport, the cylinder is now aligned with the CPlane of the face of the pyramid. So, this was an overview meant to get you started modeling quickly, cleanly, and effectively with curves and planes. There's a lot of hotkeys and quick shortcuts that exist in Rhino, and it's up to you to find them. Rhino might at first seem to have an unimaginably large number of commands, and it certainly has many, but they're very nicely grouped and sorted. Most of the commands we use in this demo can be found under the CPlanes or Curve Tools tabs up in the Rhino menu. I encourage you to dig through those, get a better sense of what you can do with Rhino. 3D modeling is a large part of it is about knowing what tool to use and when, and Rhino has a lot of built-in tiny efficiencies that really add up throughout the modeling process. Tutorials are only a small part of the process of learning, and knowing when and how to use a tool is probably the most important thing. Best of luck!